see. Let me see. Where am I now? My streaming. Okay, perfect. I'm live and I'm going to send it to my friend. Call. Great, guys. So I have copied it, but how do I make sure that it is live and everything is okay? Let us send them an email. Ramraj, I have sent you a link for my streaming. Ramu, I have sent you a link for my streaming. Would you please confirm that am I good to go? I mean, everything is properly working or not? On Gmail. Okay. Am I audible? No. Okay. So let me make it audible. Okay. Perfect. I think it should be audible because. Okay. So that's good. So hello everyone. My name is Rishi Goswami and I'm live today. So this is my first live streaming, or I can say this is my first video on the YouTube, and I'm gonna be doing some great thing here in between you, in front of you, so that you might relate it. So do you, I just wanted to give you my brief introduction that I'm a student and a BTech student, a second year BTech student, pursuing my computer science degree from a tier 3 college. I would not say it is tier 3, but it is tier 2 kind of college where companies come, they hire, but you will have to be make sure that you are very excellent uh, engineer. So that's why you need to be very good in DSA. So this is my DSA course, DSA series for which I'm gonna be doing all these things, right? So I just wanted to make sure that my array will be good, right? I just wanted to master array. Okay, 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 perfect. So this is live streaming where I'll be discussing and studying array, and I'll be making sure that you know it better than anyone, because this is the series where I would not teach you array. I will learn array and I will make sure that I'm explaining it to you so that you might relate to it, where it is a group discussion for me to you, for you and for me, right? So this will be kind of very great series, right? So let us get into it. So what is array? I mean, what is this? This is the topic of DSA, of course, and array is a kind of data structure, right? This is a data structure. What is data structure? Data structure means a structure of storing of data, right? It, I mean, how data is stored in a memory or in a computer. So this is called data structure. There are so many kind of data structure, and array is one of them, right? And here I can see that there are some historical knowledge about facts here. Uh, in earlier than where computer was built in 1940s, the problem wasn't computation, because computer was able to solve any kind of computational problem, like they can solve any multiplication, addition, any kind of arithmetic operation can be solved by computers. But the problem became more, uh, problem was of storage. How do they store data? Like they have made the memory, but in earlier sense, they have made the memory, but storing the data was also the technique when they needed to store more data in same storage of memory. Like some kind of you store the data in memory, but some kind of computation was like that. Uh, they needed more data, more storage, and some computation need less storage, some kind of computation. So that's how they needed to build a data structure, right? So the problem was not computation, it was storage. And the person who built this linear model, I mean, array is a linear kind of model. Array is linear data structure model, linear data structure model, right? So John von Neumann was the first to introduce the concept of linear memory storage model. And how does it uh, happen in memory? There is a defined cell for each, there is a defined address of each cell, right? So on a very casual note, if I would give you the example of soldiers, like first soldier, second soldier, third soldier, fourth soldier, five soldier, fifth soldier, sixth, they are all standing in a line, right? So, and they have been given a name like one, two, three, four. So they have a certain defined uh, index, right? They have been indexed with certain number. So if I want to fetch one like third person, so I will call third person and it will just come out, right? So this is kind of structure is called data array, right? So we will go more deeper into it, but let us assume this is our complete overview. I have made this PPT not to teach you, but to know more deeper into it. Like this is the overview of array. So I will copy all of that like this. Okay, I'll copy all of that and I will go and learn alongside with you, right? So I will open ChatGPT for learning so that I might relate you and I might I may have some questions regarding that and we will solve thoroughly, right? So hi ChatGPT, I am studying array and I need to make that I am understanding everything from scratch in array. So start with the introduction. This is the prompt which I will give him. Let us take a reference. So let us take a reference from MIT, Stanford, and IITs, and some great books. That's how I will give the prompt because I just wanted to make sure that my topic is from everywhere so that I might relate you, right? I might be able to. So this is kind of array looks like. We will think of it like this is continuous memory location. What is this? Continuous memory location. What is this? And some. This is called one dimension. Let me close. Let me close the door. Like, sorry guys, actually I'm in hostel and there are so many people who come and go in my room, so I will have to make sure that it is closed while streaming is on. But it will be kind of raw streaming where I'll be performing some kind of good stuffs, right? So they have given some kind of theory and let us read thoroughly. Array is a data structure that holds collection of elements of same types. Wow, that is the crazy thing. Stored in a contiguous memory locations, right? So array is a kind of data structure that holds collection of elements and collection of elements is called data, right? And it is of same type. That's a kind of property of array. Array can hold only same type of uh, elements. Like here it has hold 11, 9, 17, 89, and so on. So this is kind of integer type of data or element. So this is a complete data and it is kind of integer element, right? Data means complete and it's integer. This is element integer, right? And here we can say this is also element in integer. You can see here it is also a 2D array which is also having element which are integers, right? So this is kind of thing stored in a contiguous memory locations. What is contiguous memory location? So let us see here, right? The first 11 is stored at some memory location, right? This is something that is very important here. The first element which we store in a memory location has a kind of uh, memory address, right? So here it has been represented as 200, right? This is its memory location. The 200 is representing its address in the memory. 11 is stored at address 200, and the next element will come in that array or that data structure will have a certain kind of increment of uh, address, right? Like it is 200 and this is 204. The increment of 4 shows that the size of first element, right? The just neighbor element, right? So this is my first memory location and this is my second memory location. So 9 has a address where it is ahead of 4 unit of address 200. Are you getting? So this is kind of thing that happens. The next element comes with 208 memory address and this represents 17. I mean 17 is stored at 208. Similarly, it is 212 and 216, 220. So this kind of memory location is contiguous memory location where each element in data structure is stored at uh, kind of sequential position, right? Sequential address position. This this is not something that is very this can be random. This is just a random memory location, and the next is not just random. This is uh, fixed on the size of this, and it is not based on the size of 11. I mean, 89 is greater than uh, 11. Then how the size matters? I mean, just it it's just about the defined what do I need to say? It is just a defined interval, right? Defined period. After each period, this will go like this and increment of 4. This can be 5 also. So this is kind of memory location is called contiguous memory location. It increases while we increase the index. True, right? So let us move. Because the contiguous memory location layout, it gives base starting address, base address of the array. You can compute the memory address of okay. So this is basically saying that it gives the first in this kind of data structure. The memory allocation is only done for 11 for zeroth element, and rest of these can also be computed by uh, like this. I mean, the 200 has been defined for 11, and if I want 11th indexed value, what would be the memory address of 11th index? I will just see the difference and multiply it by the 11, and that will come 244. Like, let me open whiteboard. Whiteboard. Okay, it is taking few time, but good. I'm very prepared for it. Don't worry. Where is this configuring? Okay, perfect. So guys, this will take a few times, but once it is started, I will make sure that nothing is hindered, nothing makes you hinder. Wait a minute. My friend is just come. Start with black canvas. Okay. So what I was saying that, so I was saying if you know about the zeroth position, like this was 11 and its memory location was 12, 200, right? And you know the zeroth index has this element and its memory location is this. The only thing you need to know will be the difference of second element, I mean second element and first element, so that you might be able to get, know about the interval. This was 4, right? And suppose you want to find the memory address of 11th position. So the only thing I need to do is just multiplying with 11 with this, right? And this will comes out to be 244. Okay, and we can see here it is 244 at 11th position. I mean 11th index, right? This was not 11th position, this was 11th index, right? So that's how it works. So this is very good. In memory programming language, indexing will start with 0. So the first element, mm, like I haven't, like Python, Java, JavaScript, and every kind of language I have gone through. They start their indexing with 0 and go through all these things. So array has kind of index. Array defines when array defines, it defines with two three things like the memory location, the value, and the index and the interval. Right? It defines with some kind of these things. Right? And once it is defined, it defines the first value as zeroth index. Right? I think it is pretty clear to everyone. Array can be one dimensional or multi-dimensional. Yes, yes, yes. This is the thing which I need to make you aware of. Let us erase this. Okay. So suppose this is mm, suppose this is array, right? And no, okay. Suppose this is array, right? Suppose this is array, and you have to store some more array like the data of, like this is array, first array, this is second array, this is third array, this. So this is the array of, this complete thing is array of array, because there is a array inside it, right? There is a second array inside it. This is the second, third array inside it. So if a array is containing array, I mean here is only two array, it is called 2D array. Okay. So array has one array. This is called 2D array and this is called multi-dimensional array. So array, if array is containing some kind of information like integer and something other thing, then it is 1D array. And if it is containing one more array inside it, then it is 2D array. If it is containing like one more array here and here and here also, then it is 3D array, right? So there can be multi-dimensional array, right? So this is multi-dimensional array. Okay. Okay, let us move on. Next thing. Why do we use array? Okay, this is the basic thing that we need to use, know that why do we use, where do we need it, right? When you have many data to of same type, like for example, scores of 100 students using separate individuals, variables get cumbersome. An array lets you store them in a single structure. Okay, if you want to store your marks as different variables or something like this, like you once you like in programming language, what do you do? Let us go on this, right? Let me define. Uh, array with array session dot type pynd. Like my name is Rishi, right? Rishi Goswami. And let us suppose I scored 90, 95 in my maths exam. And suppose you are, suppose you are, this is my name one, this is name two, and use your name is Shashwat, Shashwat Gupta. And you scored one is equal to 96, right? So this is another kind of storing a data as variables. Like I have stored a data as, so there kind of some memory used here because we have make made a variable, made a string object, right? And here it I have make a integer object. Here also I have made a string object and an integer object. So it is stored somewhere in the memory. So this is my data, right? And this is yours data. And how do we storing this as a variable? And suppose I have 100 student and I'm storing them as like name 100 is equal to xyz, and score is something, score 99, right? So 99 is something 00, right? And this is kind of another data structure, and you have used something like this. So this is kind of another data structure. This is not a particular type of data structure, but this is kind of storing of data, right? And if you want to, uh, 1 minute, guys. check if someone is watching or not. Content videos. No, like one subscribe and my friend was saying it. But not very. So I was talking about this. So this is 100th student, and the storing of this kind of thing is not as like I haven't named. I have indexed my first name as name one, second is name two, score is score one, and this kind of thing. Let us say that score zero, right? So storing them like this will make so much of unavailability, right? Of they like they cannot be used further if we have this kind of inconsistency where we have defined hundreds of data. So if we want to store them, like what if we want to store them in single structure, what we can say? We can say name is equal to, we will define it like this in Python, and we will say this is Rishi. What is happening, guys? Okay, we will define it like this. My name one, and I will push my hundreds of name here like this, right? And if I want to store score, I will add like this, right? I will make sure that I have pushed hundreds of data here, and it will just remove the inconsistency where I will have to decide where I'm defining it. And once it is defined, it is stored in the memory location and it is continuous. So my accessing, my order of accessing the data will be constant, right? So I will talk about it later, but like I have got 100, let us suppose, and 95 and 90, 68, something. This is so this kind of data are there, right? 90, and let us. So I have stored my name in a data structure, and this is sequential. If I want to access first my first data, I will access it by saying name as 0, and it will access my data, right? And if I want to access the my score, so I will just write a score and 0 element, right? And that's how it's gonna work. Please, 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 God, connect to it. Okay, okay. So my score is 100. If I want to check my name, distribution. That's how it works, right? So if we want to just store them in a single structure, that's why we need this. Because contiguous memory and same type of parameter. Oh, that's kind. This is the best thing which I want to discuss here. Like if because of it is contiguous memory location, contiguous storage, and it is storing of same type of element, the array provide constant time accessing of any element at any index, and that's I want to discuss it. So I have read. Suppose you have a collection of books, right? You have collection of 10,000 books, and that is scattered in whole room, right? And if you want to fetch a particular book from that room, so how would you go through? I mean, there is some kind of scattering, and you don't know where it is. So it will take much more time. You will have to go through each book and read that if it is book or not, and if it is book or not. So you will have to go through it, right? And if you have consecutive books, like you have settled them into their names according to their names alphabetically. So if you want the name of the book, you can easily fetch them. Like you will go through not all the books, but you will go to some kind of their alphabetical pattern. You will find the alphabetical pattern and you will just fetch it. And this is kind of constant time access. So I just wanted to make you think it like this, right? How it is constant. Let us suppose you have defined a memory array like this, array of five uh, integers, like array of it is five integer of it is array of five integers, and here it is five integer. So base address is base address is 1000, and it is defined for a memory address. So base address is like this, and the zeroth element will assign this address. Zeroth element will be assigned this address 1000, right? The next element is 100 1004. Did you get this? My second element, or my first index value, is 20, and its address is my second element, which has first index, has assigned this memory address. This is the memory address. So suppose I just wanted to fetch my second element, which is first index. I will just go through this address and pick that. Once I go through this, I just pick that element, right? So this is kind of good structure. Suppose I want to fetch my fifth element, which is index 4 element. So I will just go through this. I will do some kind of 1000 into 4, because index is 4, and 4, because the difference is 4. So it will come out like 1016. And once you know the memory location, all kind of accessing is done by this. So this is just some mathematical computation, and you know the memory location. And once you know the memory location, you can fetch easily, right? So this kind of thing allows the array to fetch them in a constant time. So this is very basic to know, right? And this is my second thing. This is this is how it works, like array of address of I am finding the address, and this is the Java syntax, right? So this is the thing. That's how it fetches in constant time. So let us revise how does it fetches in constant time. So once you have defined an array of any size, let us suppose n size, like, right? And you have given a first value, zeroth index value. Once you give the zeroth index value, it defines a base address of its address. Like base address is defined the address of first value, I mean zeroth index value, right? So if you have assigned this value, the next will be assigned as some interval, like particular a defined interval. So once you have assigned the second value, it will just give you the difference, right? The second address and the first address will have a certain kind of difference, and that difference we will use to find the next address, right? So suppose you will have nth indexed, like nth indexed value. So you will just add base address n into n, base address plus n into the difference, and it will make you find the address of nth element. Not nth element, it is nth indexed element, right? So this is kind of thing happen in array. So if you have the address, particular address, then it will just fetch you the element. It will not, you do not have to go through all these things. You just have to compute the memory address, and if you have the memory address, you just draw it, you just fetch it in a constant time. So that's how it just was, right? Let us erase this all and go through the next thing, which is cache locality. What is the cache locality? So array uses, caching uses array, right? What is caching? So let us see if there is any kind of other thing here. Okay. Nothing. There is not caching, so I will have to go through it. So there are three things in computer. First is which, okay, let us see. There are three things in computer. First is this, second is this, and third is this. So I have made it very clear that this is CPU. I'll make sure that I can write very properly. This is CPU. This is cache memory, and this is other thing. Let us say RAM, right? What does CPU do? CPU just like imagine this dashboard. I just selected this, my blank pen. Like this is black, right? I have selected this pen, and this selection, like the process of clicking this and getting this, is done by my CPU, right? But I just have done some experiment. I just have done some this thing. It is what it is. It is my um, collecting some data. It is stored some, it is stored on a memory somewhere, right? And this is stored in RAM. Did you get this? Okay. I have I just want to delete it. I have deleted it, right? So if I have deleted it, where does it went? It went into this cache, and it is stored in a cache. And here this button redo does the same. It fetches from here. Did you get this? So on a very serious note, I just wanted to make you realize that, please. So every task is performed stores some, uh, like CPU performs some tasks, okay? RAM stores them, RAM, ROM, SSD, everything. This kind of memory stores them, and the thing which have been deleted or just not in use, right? They will be just cleared later on. They are stored in cache memory. I mean the temporary data that will be cleared further, that are stored in a cache memory. So imagine you are scrolling Instagram, and you have some kind of you have watched reels, and certain very, what do I need to say? Occasionally, I just use my all data, like the 100% notification has come, and if I'm using 4G, if I'm using 5G, then it is unlimited here. So if all my data has gone, I can watch all the reels that has been watched. So this kind of data, this kind of reels are stored in the cache memory of Instagram. So Instagram takes a cache memory where it stores the data. And once you close all the terminals, like all the windows of Instagram, it just it just clear them. Cache memory clears them. But if you haven't closed it, and you are using from, like, you have come from somewhere and just opened your all windows, and you find there is Instagram, and you want to scroll, but you don't have internet. So you will go through that, and you can watch them thoroughly. If you haven't closed them, close the window. So this kind of memory, like this kind of reels are stored in cache memory. So they are stored in cache memory, and they can be fetched very easily on a very constant time. You do not need this kind of thing. So CPU CPU can access, CPU has a kind of memory that is called register, where something grades are stored, and their accessing time is 0.5 nanosecond. And there are three levels in caching: level 1, level 2, level 3. And it just moves around from 1 nanosecond to 100 nanosecond. Once we want to fetch some data, so it will take this amount of uh, time, right? And if this RAM, so we usually say that RAM is very fast, but in comparison to them, this takes 100,000 of nanosecond to fetching a data. Like, this goes near around this time, right? So when we compare these kind of memories, so caching is very great memory if you want to access. So this cache uses array for accessing. If you want to access them, you will have to use array. I mean, if there is caching, there is array working behind it, right? So I think it is clear, and if it is not clear, I think it just hit it somewhere where you can understand it very easily, right? So this is kind of thing is known as caching. So in caching, it is done, right? So it is done, right? Array serves as a foundation or building blocks. Many other that is very important to know. That is very, very important to know that array is not just a uh, data structure. It is the building block of other data structures. Like, if you have heard about stacks, queues, hash tables, hash maps, and many things. So this is a building block of them. Like, stack one array one. Let us suppose that You have defined an array. You have 5 from here. Let us suppose this is my array and it has some kind of value. If we want to access them like this, so this is array. If there is not any restriction around here, so this is array. But if we want to access using this technique, LIFO technique, last in, first out, first out, right? This is technique that is, last in, first out, first out, right? If we have inserted a array, not an array or any data into the array at last, and if while fetching them first, like there is a, okay, let us draw it here, 5, first, at first you have inserted 5, 6, then 7, then 8, then 9, then 10. So you have stored it like this. At first 5 was stored and at last 10 was stored. So this kind of, if we want to perform LIFO task, LIFO operation, last in first out operation, it will just store them like this, where 5 is here, 6 is here, 7 is here, 8 is here, 9 is here, and 10 is here, right? So if we want, now if you want to fetch any kind of data from here, you will have to first remove 10. First in, last in, first out. So 10 will be the first element which will come out, right? Then now if you want to perform first in, first out operation, and this is called stack. This kind of operation is called stack. This kind of data structure is called stack, right? And if you want to perform FIFO, first in, first out operation, like this. If you want to perform like this, if you want to remove this data first, so this will remove first element if it is stored as a first. So this will act as queue, right? So this will be doing like this. So this array is a basic structure. Like if there is no any rule to fetching or deleting or something like this. If there is not any rule, then it is array. If there is a certain kind of rule like LIFO, then it is stack. And if it has, then it is if it is a rule of FIFO, then it is queue. So I think it is pretty clear. So thank you for understanding of this. So array is a most important thing, right? Okay, let us see how many people are watching. One watching now. If it is a rule of FIFO, then it is Q. May, can I not see this? Okay, okay. No problem. Okay, good. Not a problem. So let us go more deeper into it. So some important characteristics of trades of, okay, and trades of. So array is fixed size, and here in PPT I have said, here we can see that if I have defined array, if we have defined an array First, we have defined it is a kind of integer. The data into that is integer, and the size of that array, I mean the amount of integer that can come into array is just 5. So this is fixed size, right? This is, I mean, if you want to add some more element into this, it cannot be element stored. This will give something error. This will give error because you cannot add more data because it is defined as it is a 5 element data structure. Okay, so this kind of thing happens usually, and there are some data structures that are dynamic. Like this array can be turned up into a dynamic array. So we will do it. This is dynamic size array. Okay, right? And list in Python, like there is a data structure in Python called list. List is a dynamic size array where if you want to add more data, it will just add without doing anything, without fetching any error, right? In many languages, once you declare the size of any array, it cannot be changed. This is called a static array. And for some languages and framework provides dynamic array underneath, but conceptually it is still a array. So there are some languages like Python provides a dynamic array. I mean, a array that is transformed into a dynamic array. We will do a kind of problem. We will redefine array into a dynamic array, right? So contiguous memory that we have discussed earlier, good for locality, caching friendly. Okay, there it comes. Here it comes. And predictability performance. This is kind of good thing. Like if we want some data to predict, but inserting and deleting in the middle can be expensive. Okay, so this is something that we need to go through because you have like let us see that you have defined a array like this, right? Here it is 1, it is 2, 3, 4, 5, 6, 7, 8, right? And if you want to insert 4.5, so no, just let us suppose you will have to insert 9 in between, 9 in here, like in between this place. So this is zeroth element, this is fourth index element, this will be the fifth index element, and earlier this 6 was fifth index element. Now, if you want to store 9 in between, then this will be the sixth index element. So, and now this will be the seventh index element, this will be the eighth element index. And if you have large amount of data, then all the data will be getting hindered. And this is very costly uh, in terms of time, in terms of capacity. So this is kind of very costly and very expensive in array. If you want to insert or you want to delete, like if you want to delete 4 from here, so this will not be fourth index value, this will be third index value. So it will hinder all the data after that. So this is kind of very expensive, and it this kind of problems give born to linked list data structure. If you have heard about it, linked list, right? This will give on to another data structure where deletion and insertion will be very good, right? I think it is clear that, but inserting or deleting in the middle can be very expensive because you may have to shift very many elements, right? Indexing cost. Accessing by index is strong, but the operations like insertion, deletion in the middle, resizing may not be as efficient. Yes. Insertion cost is very low because indexing cost, indexing cost is very low, but insertion, deletion, and resizing and something other like operations you want to do some another kind of manipulation that can be expensive here, right? So this is very easy to understand. Multi-dimensional array, this is also a great concept here. Like you can store array into array and still that will be an array, right? This will be called a multi-dimensional array. So why do we need this multi-dimensional array? If you have heard about matrix, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this is called matrix. If I want to represent them into my data structure, this is matrix and I want to represent in I want to do some calculation within my computer. How will I represent them? I will just collect this as my first data structure, first array, 1, 2, 3. This will be my second data structure, second array, 4, 5, 6. This will be my third array, 7, 8, 9. And I will have to make an array of these arrays. I mean the array of these three vectors. And we know that these are the vectors, like one unit in X, one unit in Y, and one unit in Z. So this is called vector, and I have stored them in a array. Second vector is stored in second array, and third vector is stored in third array. So this array is stored here, and I have made a separate array of this complete thing, right? This is called array of array, and it is called matrix. Like in programming, if you have a 2D array, this is called matrix. It performs, if it has some kind of property that follows the matrix properties, then it is a matrix. And we have lots of questions on that. That is called matrix. So I think so. This is the only thing that we have to think about. So multidimensional extend the concept of array into grids and tables for 2D examples, but the memory layout measure, row measure, column measure, important. Okay, that's nothing to worry about. So there is some kind of formal definition and representation from one of the book. Array is an entity whose objects are sequence of elements of same type and and the two operations are performed are in stored and retrieved. Okay, so there is a array is a kind of data structure where two operations are performed, storing and retrieving. Because this kind of operation is done in constant time operation, and we know that the constant is very much efficient uh, operation. Also, an array is a collection of homogeneous data items stored in a contiguous memory location. So this kind of definition will get we know what the exactly is. When you represent an array in memory, let the base address be b. So if you want to store a array in the memory, the first element address has b. The first element has a base address. I mean, first element is stored in a base address that is called b, and each element takes k byte, right? Like I have said that if it is that was 4, like let me show into let me show them into. So the difference was 4. So this is saying that each element take 4 byte, for example. So like integer is kind of x byte. So for example, it is taking 4 byte. Then the address of the next element will be, or ith index will be b plus I into k. So this is why index is access by index is constant time, right? So where do top institution reports? So this was the complete reference. Okay. Is there anything left? No. So we have gone through every concept of every introduction of array, right? Now we will be moving on implementation, right? So this is kind of thing that we need to discuss here. So the thing we will have to discuss is manual implementation. What does this manual implementation mean? We will have to define an array where we will have to define base at the kind of array, the size and everything. So this is kind of very good stuff to do. And I don't know about C language, but here it is the code is given in C language. I don't know about much about it, but we will ask ChatGPT to um, give them in Python or Java. I know Python and Java, but I think it will be very easy if you go through Java, and it will not make some problem, right? So int main. So I know very basic things like this is a standard IO. This stores this printf function, printf method, and standard library is malloc. I don't know this is much. So this is memory allocation of this kind of thing, and it is kind of added data integer, and n defines the uh, that this thing, right? So let us go to ChatGPT and ask, let me know about the manual implementation in Python using C library. Python provides a library that is called C library, and all the functions that in C that are accessible in Python. So it will be very easy because the Python is self-made language, and it is kind of Python is a language where um, it has not been made from scratch. It has been made using some other like C language. So Python has lots of built-in data structure like lists, so we cannot make it here. But using C library, we can easily make it. Python's built-in list is a dynamic array, but it hides the detail of memory location, resizing, type constants are not there. So list is a kind of data structure where you can store non-homogeneous data also, data items, like you can store 10, 15, something like this. But when it comes to the topic of array, it is kind of homogeneous data structure, right? So array is a module that provides in C type only. Okay, 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 okay. So here we have imported array. Mm, good. So let us copy it and manual implementation dot ipynb, and where will be doing this, right? Right. So I have imported the C types. This is called C library, and I have defined the ChatGPT has defined my array, and the base, the instances we have to define is the size. The size is very important. Like if I want my array to be um, five size, like size of five array, so this kind of thing should be there. So data self dot data C types C into data. This is kind of function that we need to know, and it stores the allocate the allocates memory for size integers. Okay, like malloc C types dot C int. Okay, C library. We have imported this C library here, and we are accessing it, and we have fetched some features like C int, and it is kind of integer. Okay, into size, there is the defined size, like integer. This is integer and of size 5. Okay, 5 size, and it is defined. So data are here, right? This is the data that we have. I mean, the memory is like this. Not memory. I'm sorry for it. But the kind of structure we have built, like we have built a bracket where we have allocated the data. So the data over here is not in the bracket, large bracket, but in defined is like this. So C type and integer of 5 size. This is an integer of 5 size. So the data will be stored here, right? So get items is also a const. Okay, some function. If index is less than or equal to 0, and if index is in between 0 to length, right? If it is between in between, return, okay, data. So this is kind of also right. This is the complete data set. I mean, this is the another way to write this, like, mm, let us do some real quick experiment. So we have seen that I have stored some scores, right? Score is like this. I have used this parents, this kind of bracket, and it was used in Python, right? This was in Python, and now we have seen that in Java, this was like this array of int type array of size 5, and the data was stored in this curly braces. This kind of syntax was in Java, this kind of syntax was in uh, Python, but in C type library, the data will be stored in this kind of um, syntax. This is nothing but uh, this in Python and this in Java, right? This is very equal to this, very, very equal to this. So we have to get, we have defined a method to get the item at index, some index, right? And here we have checked the constraint that the data is the index is valid or not. So if it index is valid, then we have returned it, and if it is not valid, then we have raised a error that is called index out of bounds. I mean, index is not in the range of the length. So, and there it is setting the item, right? Like if you want to set an item at some index, so if index is valid, I mean, if it is in between the data, then we have just replaced or just added the value here. Like the score was 5, 4, 6, 8, 18, and 9. And if I want to set a new data at index 1, like I want to um, replicate, I want to just remove, um, what do I need to say? I want to replace this 4 with 7. So I will just replace it through this operation. Like if the index is good, then I will just do this, and it will replace the 4 with 7, and this will go like this. Rest of part will be like this. So I think it is very easy to understand. And if it is not, if the index is valid, not valid, we can also do this return, and we can remove this to this, right? And this is very good. So I think this is good to go, right? And there is a append function. If the length is if the length of data, I mean the length of data was this. So if the length of data was equal to the size of data, like we have defined the size and the length was initially 0 and we didn't have added anything. So size was the fix and length was 0. So the data, if we want to add any data, then it will store that data, right? And if we have not if and if we will increase the length, we will increase the length of that data. But if the data is if the length of the data is equal to the size of the data, then it will raise an error that is called overflow error, right? Very good. This is called representation. Like let us print all the data. The second element was 20, and so I have made an array of size 5. We have added 10, 20, 30. This is append function, which append method where we have added 3 elements and we have printed that array. My array was like this, and then the second element was at index 1 and it was 20, where we can see that the second element is 20 and here it is 20, here it is 20 printed. And if we want to replicate it, then we will have to just make sure that do this, right? And there is also one thing that we can do, like set item array, what is this, array dot underscore underscore set item as index 1 and 99. Will it work? Yes, it will work because we have called this method here. But if we want to do something crazy, then we will have to just make sure that we just wanted to second index. We have changed the second index into 98 and it will work. Right? The second index is changed and the value is 98. So this kind of operation that happens here. So I think the manual implementation is understandable, where we have defined the size of array in Python, where we have done it, and we have added some values. Like here we have defined integer that is called I, and if it is less than one, less than n is the size. We have added the element into there, right? And we have printed all these things, and we have freed that uh, memory location. So I think the manual implementation is understandable to you. And if you have gone through all these, let us try to build, right? There, here we have data set. Okay, let us try to build. So import ctypes and okay. Where my phone is. Hello. हाँ 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 बोलो. अच्छा ठीक है. हम्म. नहीं नहीं ठीक है ठीक है. अच्छा ठीक है. I think it is time for my dinner in the hostel. Okay, so let us define a class that names array, right? And we will be defining some instance variables like size of size, right? And self dot size is equal to size. And what do we need more? Self dot data is equal to, what was this? Ctypes dot int c int of into size, and this was function to build this, right? I think the syntax is correct. If it is not correct, we will going through. Self dot length is equal to 0, because at the initial point of time there is nothing in the uh, array, because we have created a array object of size 5 and there is no element, right? So this is kind of here will be data, here the data will be stored, and the length of that data is 0, right? And then we will have to create a method where we will be accessing, right? Right, accessing of self from index, right? So I want to access the element at index I, right? At some index, right? So I will not write exactly as index, because I will write I, right? So if I want to access, let us um, draw up something like if it is less than or equal to index I, or it is greater than uh, self dot size, then raise the error of index error, and it will what it will say, it will say index, please give the right index, right index to fetch the value, right? And if it is not like this, we will raise this error. I'm confused if this raise will be, let us a return function. Okay, this will not work. So if we have something like this, so what will I do? Self dot data return self dot data dot I. So initially I was just at some point I was confused if the raise is used, will it allow the next thing to perform or not. So if we have written raise function, raise keyword. If we have written the raise keyword, it will not allow the next thing to perform if this condition has been done. So this is good to go. And next thing was set element, right? Self dot index index comma element, right? Let us suppose we want to set an element at index at some index. Okay, so what will I do? I will just make sure that that index is um, in range, right? If 0 is if I is greater than 0 or less than, this is not I, this is index, and if it is greater than or equal to index 0 and less than self dot length, self dot size, right? Then I will just add, or what will I say, I will just do self dot data dot index is equal to um, LE, and I'll just do return to just end the function. And if it is not like this, then raise the index error as please give the right index to to like this. So this is kind of thing that I have done. And if I want to append, like I want to build a append function of, so in that object, and this is what it is. I want to append an element, right? Element. So if this is true, just copy it, paste it, self dot length plus 1 is like this, not minus 1, just plus 1. What is it here? It is plus 1. Then I'll just do it. Self dot length plus 1 equal to like this, and then I will increase the length self dot length plus equal to 1, right? And if it is full, right? And if it is full, then raise the out. What was that error? Index error, not overflow error. How the Data is full error, right? So this is kind of my array that we have. This is kind of our array that we have defined from scratch. So this is very good to know that we have done something very great, right? Right. So this is the thing that have been started from here. Let us take a break of 1 hour. I think that will be good. And after that, what we'll be doing? So we will be building. We will discuss what is the problem. Like we will discuss in more detail, and then we will go on dynamic array, building this and operations. Then it will come some greatest topic in our whole life, and we will be doing searching, sorting, prefix, suffix, sliding window, do some problems or 2D array, matrix, and advanced rearrangement problems, and then we will be moving on CP problems. So this kind of thing we will be doing uh, after the break. So let us take a break of 2 hours. I think we have whole night and whole day to do some crazy things in our life, right? Very right. So thank you guys for this amazing session, and thank you for me that I have been very clear on my side. So thank you very much. Let us end the session here, and we will be deciding. OBS stop streaming.